honor to be the first guest this morning. We have a long road together, so 6 presentation. So I'm going to try to make it as fun and entertaining as possible for a manufacturing presentation. My presentation is titled Smart AI Camera, but I'm not going to talk about Smart AI Camera. Instead, I'm going to ask you a question. Doesn't work. Good. Don't worry, you don't have to answer yet, right? It's just 10 o'clock, it's your first coffee. We're gonna come back to it after. But I want you to think about this actually in the prospect of vision and AI. So maybe to start a little bit about myself. So I'm Lucas Vandroux. I'm the founder and CEO of Biel. So we're a ETH spin-off founded in 2020. We specialize in visual quality inspection using deep learning, so usually very specific, complex, and subjective problems. Personally, I've been studying and researching computer vision and machine learning at EPFL, ETH, other part of the world for some companies, and then in 2018, I focused solely on manufacturing. To start a bit and to explain, like my goal for today is to give you the tools to actually be able to understand how those like smart AI cameras are working. Like, what's the technology behind and what's kind of like the mental tools or the mental representation you can use when you're like considering such technology, buying such technology, or like using such technology. And I think today, I mean, if someone don't agree, please raise your hand and stand up. But like that's what visual quality inspection looks like in most of the cases. There are a lot of already automated. There is a lot of visual inspection, but there's still a lot of manual work. A lot of people looking at parts, either with their own eyes or with actually microscopes. And then this comes with like different problems. I think one of the main numbers that we know, it's like a starting to be a relatively old study, but it's relatively say an average accurate number, is that 87% is kind of the accuracy of a human operators. And then around this, we have a lot of different processes, we have a lot of different techniques that we can use in order to increase this accuracy. And I mean, this has been known. I mean, you see it every day on a factory floor when people do visual inspection. But it's been also 50 years that people have tried to automate this visual inspection. And first, it comes with, I think, what all of us know and have seen at least once, those rule-based type of visual inspections. So I'm going to look at an image, and I'm going to define some very specific rules about what I want to see in this image and what I want to extract. So I'm going to take a very simple example, far away from manufacturing, but just making a differentiation between cats and dogs. So I want to define specific rules about cats and dogs. I'm going to define one very easy rules for cats. If at the top of the image there are like 2 triangles, shaped things, that might be the ears of the cat. So potentially this image contains a cat. And then if at the middle of the image I have like kind of a dark spot, circle, that might be actually the nose of the dog. And then I have like my 2 rules. I cannot guarantee you it's going to work 100%, but it's to give you an idea of the type of rules that you would define manually. And the idea about this, and what I want to spend time to explain this actually, is that deep learning is actually not too much different than this past technique. The only thing that you have to kind of like add in this process, that this time you are not the one defining the rules. This time you're going to give data to a system, so images of cats and dogs, and you're going to let this system decide on what are the rules in order to differentiate from cats or dogs. The main difference is that in our case, it's a computer, it's not a human, so you're going to have thousands, millions, or billions of rules, actually, that the computer is going to be able to define and to use in order to differentiate it, making it a much more robust system. And that's where maybe the one thing you have to remember from my presentation is that because AI and deep learning rely on this data to define the rules, then it's actually the data that are the most important in those systems. And this is what's going to come along in my presentation. It's always about the data, in quantity and in quality. Everybody follow so far? Okay, good. So then I'm going to go through 2 of the main questions that comes back all the time. I think other people here in the room also sell smart AI cameras, so I think that's also some of the things we present and we like to show because it looks a bit like magic. But we hear in the press, for example, OpenAI spending months, millions or billions, to scrap all of the information from the web to train their model. It takes a lot of time, it takes a lot of efforts. And then you have someone that comes to your factory with like a camera and they say, hey, look, you give me like 30 images and I can train a model to actually do this visual inspection task. And it works. And here you can ask, like, what's the magic trick, And here what you have to understand, there are two things that makes this possible in manufacturing. It's the same technology that is behind, but there are two things on top of it. The first one is that actually the models that are used to make the detection in your factory, they have been already trained. So actually this long period of time using like millions of images, a lot of time, those models have already been through this. And they're actually very good at doing way more complex things than visual inspection in manufacturing. They could even be using, for example, self-driving cars to detect pedestrian signs and everything. They're already able to do this. So they already have like a list of numerous rules to detect a lot of different things in the images. And what you're going to do with those 30 images that you're going to give to the model is that you're going to specialize this very good model to do a lot of things, to do one little things very well. So that's one of the points. And the second point is that actually in manufacturing, you are very like limiting the environment, you are like, controlling it. It's not a self-driving car, like Tesla is still collecting images on the road and still like their car is not driving by itself. But in manufacturing, you're going to control the light, you're going to control what type of thing you show to the camera. It's mostly going to be always the same parts. So all of those degrees of freedom, they allows you actually to use a lot less data in order to actually get a system that is very efficient. But that's also something you have to remember is that if suddenly you want to kind of like open your inspection, for example, you don't control the light anymore, it's like in the factory floor and you're under like a glass ceiling and the light is changing the whole year on the whole day, then this is going to have more like degrees of freedom, and then you're going to need to add actually more data to this system in order to be able to keep its performances. And the second question that I was is like, can the deep learning actually model detect a defect that it has never seen before? And the answer is yes, but is that what you want actually in manufacturing? So I'll say two-part answers. For the yes part, I think if you want to have a mental image of how this works, I told you about all of these rules that the model defines. And then in most cases, you're going to take all of those rules and you're going to like decide about what the model should do with those rules and give you basically a pass or fail, or maybe a bit more complex in terms of what you want to know specifically about this specific vision inspection task. But before you have this pass or fail at the output, you actually have all of this list of rules and criteria. And for example, if I have this image of half a cat, half a dog, I'm going to have like pointy ears and round nose already. And then if the model, I told it, hey, I only want to know if it's a cat or a dog, then it's going to have to make a decision. So basically, let's say most probably it's going to be a cat, but like with a low confidence score. But if you go and you look in the rules, you're going to see that both actually of those kind of criteria are met. So you could already detect that's actually something anomaly is happening. So an anomaly detection. That's a bit of a representation of how this happened and how can this be done. Question is like, is this something you want in manufacturing? I think in most of the case, not, for the simple reason that you're not going to run in production a system that you haven't tested on defect at some point. So in any case, you're going to need images with defect. So if you have images with defect, why not be sure about how your system is actually acting and really like supervising and testing it for the specific defect you have. That depends on the use case. Good. So now, quick rules that you might keep in mind if you're thinking about going or using deep learning or not for a specific visual quality inspection task. I think there are two things that make deep learning very useful. One is that basically if the problem is too complex and you cannot define the rules. So just to give you an example, if you have something where the light is changing, or even like if it's cobots that bring the part in front, and that it's not precise enough to bring the part exactly at the same place, exactly at the same every time, then you might not want to actually define rules that specify on the very area of pixel. Just like use a deep learning model that's going to take into account all of those different degrees of freedom, the different position of the parts. It's going to be a lot simpler than defining all the rules. The second thing that's actually very interesting is that if the problem is subjective, meaning like I'm gonna have an operator that looks at the image and that give me a specific score, like this is a pass or a fail. I have a second operator that's gonna look at the same image and they're gonna give me a different result, which actually happen usually quite frequently. But at the end, you're gonna get the whole team, the whole quality team, and they're gonna sit down and they're gonna make a decision together. You can actually do the same also with deep learning. And the way you do it is that instead of giving just one answer for specific images, you're going to have different answers from all of different operators, and you're going to aggregate them. And so at the end, you're going to get the same result as if it was the team of people that was actually looking at the image instead of like the result of only one person. So like, those are two things that are very powerful that you can use for deep learning. For the thing that actually, I think you should not spend your time using deep learning and using traditional system really works, that if you need to do measurements. Don't expect a deep learning model to measure something for you. You can use it to detect something specific, and then after count the pixel, for example, that has been detected. But like wanting the output of a specific precise measurements is usually not going to be precise. Second thing is if you want extremely fast speed. Like the hardware is increasing, improving every year, every month, if I may say. But still, if you have to inspect 1,000 parts a second, I think most of you, most of us are not in that cases, but there's still like way better hardware, way better optimized system that can do this at speed. And the last thing actually, if you can define specific rules for your problem and you already have a system that can do it, then just use it. Like if you have a very precise machine that always put the part exactly at the same place, and you can like 100% accuracy say, hey, this pixel is black, it's pass, this pixel is red, it's fail, then just use it actually. It might be even faster and easier to use than deep learning in those specific cases. Good. So I've been talking a lot about data, saying like, hey, data is what actually drive and that you control your deep learning system. But what you have to think about is that data doesn't come just when you start to use AI in visual inspection. It needs to be actually a process that you put inside of your factory. And today, I would say, visual quality inspection processes in factories looks like this. So people are going to inspect, they're going to look at things, they're not going to take pictures, they're not going to keep those images. Maybe they're going to create a paper defect catalog somewhere. And then you're not going to have like real-time information about what's the visual quality inspection is happening. You're not going to have like a history of the discussion that's been happening on all of those different quality cases. And actually all of this data, that's what a deep learning system is using to actually be the best at what it does. So doing visual quality inspection using the data. And so this is also what I'm trying to bring here as well, is that it's not only about smart AI camera, about cobot, but it's also about changing the way visual inspection is done and really starting collecting this data. Like the people who already started collecting this data, so like images and information about quality that happens inside the factory, they are the ones that are the most well positioned to then actually really, harvest the results and the benefits of AI and deep learning. So to come back to these questions, I guess maybe you have an idea of what I'm going to say, but I think the answer is yes. Swiss quality can survive the retiring workforce, and actually it has to, for the sake of us living in Switzerland and living from manufacturing. But one thing is that to be able to do this, it's going to be more than just buying smart AI cameras and putting this in processes. It's going to be actually changing the processes of the visual inspection, being able to collect those images, being able to collect the knowledge of those people that are going to retire. And we can do it today. You don't need a smart AI camera. You can collect those images and information about those images. And that's what's going to let system after be able to do the same job as they were doing when they're going to be gone, and nobody's going to want to do this job anymore. And then the last part after the vision is basically to have a cobot or robots that's going to move those parts under the camera to take the pictures. So I think an image is worth 1,000 words, or a demo is worth 1,000 words. So we have a demo in the S3C that is installed with the cobots. So if you have more questions, or if you're a bit more interested about the topic and the things I've been describing here, feel free to come visit us afterwards. And I thank you for your patience and your attention, and wishing you good luck for the 5 next presentation. Thank you. you.